All right, so let's take a look at 8.2. Now, 8.1 is fairly intense, especially if you didn't pay a lot of attention, didn't take good notes, or didn't practice much with the exponent rules much earlier on in the year. 8.2 is much more straightforward. So let's take a look at how do we solve things that have weird fractional exponents. So a quick review first. All right, so let's say we had something like this. So we dealt with square root units a long time ago. What was it, unit 3 or 4, something like that. And we talked about our procedure for solving these. So to kind of boil down our procedure to its basics, we had to isolate the root. We had to square both sides. And then we would kind of solve whatever's left over. So that was our basic procedure for how we approach these. So step 1 was to isolate the root. So I could subtract 3 from each side, give me 2 square root x minus 4 equals 16. I can divide both sides by 2, give me square root x minus 4 equals 8. All right, so that's step 1, we isolated it. Step 2 was to then square both sides to get rid of that square root. We talked about how squares and square roots, or parabolas and square root graphs, are inverses. So we're using inverses to cancel them. We get our x minus 4 equals 64. And finally, we could solve whatever was left over. Now, this is a square root. It is a fractional exponent. We could have written this as a 1/2 power instead and actually gone through this very similar procedure. So what our goal here is to get a basic procedure in place to try to solve simple equations that have fractional exponents. So let's take another look at that exact same problem, but we'll just make one little change. What if we had that? It's no longer a square root. Now we have, in this case, a cubed root. So we need some kind of general process that we can use to try to do this. And we're going to base it off our previous one. Well, first step still looks the same. I mean, if we're going to try to get rid of that and we don't want to use logarithms or something, then we'll go ahead and try to isolate that. But we're no longer necessarily isolating the root. We're going to isolate whatever weird exponent there is that we want to get rid of. So let's isolate the exponent term. So I'm still going to subtract 3, giving me 2 times x minus 4 to the 1/3 equals 16. And we're still going to divide by 2. All right, so that looks better. That's basically the same thing. Now we can't square both sides. If we squared both sides, we'd get 2/3. That's even uglier, so that's no good. Cubing would work in this case, but we're trying to look for a general case. So whatever is right here, we want to raise it to a power that's going to make it cancel out. And we know that exponents raised to an exponent multiply. So what we're looking for is a multiplicative inverse, or a reciprocal. So we're going to raise both sides to the reciprocal power. So in this case, we had a 1/3. So I'm going to flip that upside down. It becomes a 3/1. And that's what I'm going to make the power. 1/3 times 3/1 is just 1. It cancels out. And over here, we'd have 8 to the 3rd. Let's see. 8 to the 3rd is 864. 512. So we have x minus 4 equals 512. I hope. It's kind of late. And then our third step is we can just solve what's ever left over again. So solve our leftovers. So I can add my 4 and I'd get x equals 516. So it's an almost identical process to something we've done before, as long as we don't have something crazy, and we're just working on practicing using weird fractional exponents. This is not that bad to do. So what I'm going to do is I'm just going to go over kind of some examples, look at a couple of them, kind of approach how to do it, and then that's really it. This is a fairly straightforward lesson, especially compared to 8.1. So let's take a look at a different one. How about we do 2 times x minus 3 to the 1/5 equals 4. All right, so we have our basic process. Step one is to isolate the root. So we need to make sure, okay, there's nothing else being added or subtracted, but we do have a coefficient. Now I will say that the two most common errors I see in these sections is one, not getting rid of the coefficient first. Don't raise it to the power yet. People tend to forget that. You'd have to raise that to the power as well, and it's just kind of a mess. So get rid of the coefficient first. All right, now that we have that, we're going to raise both sides to the reciprocal. We have a 1/5, so the reciprocal power would be a 5. So I'm going to raise each side to the 5th power. 5 and 1/5 cancel. We have x minus 3 equals 2 to the 5th power is 2, 4, 8, 16, 32. And then I can add my 3. So we'd get x equals 35. All right, let's take a look at another one. Maybe one with weirder power. All right, how about 5x minus 14 to the 5/6 equals 32? All right, well, this time we have a stranger power. So let's see if that makes any difference. So step one, isolate. Okay, we're not adding or subtracting anything. We don't need to combine stuff. There's no coefficients. That step's done. Second step, we're going to take the reciprocal power and raise both sides. So it was 5/6. Our reciprocal would be 6/5. So I'm going to raise each side to 6/5. 5/6, 6/5 cancel. We get our 5x minus 14 equals 32 to the 6/5 is 64. That brings up the second point. So the first mistake people make is they don't deal with coefficients. The second one is if you're doing this on a calculator, be careful how you enter it. Make sure both the 6 divided and the 5 are up there in the exponent. A lot of people will put 32 raised to the 6th power, then divided by 5, and that will be wrong. Most of our graphing calculators at this point will follow order of operations. So make sure it's actually doing what you want it to do. Okay, now we're going to finish off our procedure. We need to solve it as left over, so we get 5x equals 78, and then we could divide by 5. So we get x equals 78/5, or if you feel like decimals, that would be a, what, 1615.6. I say it out loud and I write the wrong number. Yeah. All right, we'll do one last one, I think. And that's kind of it. This is a pretty straightforward one. You're just putting them in and kind of running the procedure. We're just kind of practicing working with these weirder exponents. All right, how about something with lots of weirdness going on? All right. So now we have a lot more going on. There's like numbers in here. We have a coefficient here, but it doesn't matter. When we look at these, we're only looking for what is being raised to the weird power. And that's this entire term is being raised to the 1/2 power. So when we go to isolate it, we have no coefficient out here. We have nothing being added or subtracted. So we don't need to simplify or isolate it. It's already done. Now we go to reciprocate the power. This is a 1/2. So our reciprocal would be 2/1. They cancel. We're left with this whole ugly thing, whatever it might have been. Then over here we have 3 squared, which is 9. Now we can solve this as a simple linear equation or quadratic or whatever we might end up inside. So I can add 8 to both sides, get 1/2 x equals 17, and then finally multiply each side by 2. Get x equals 34. This is our basic thing that we're practicing for 8.2. It's not super difficult, just be careful of the common errors that I've pointed out. Make sure you're careful with your calculator and what you're typing in. Make sure that you actually get rid of any front coefficient before dealing with the exponents. And that's pretty much it for 8.2.